The last type of problem that we'll see is that special case that I was talking about in part 2 towards the end. It's when we end up with only one or no answers. So there's 3 different types of answers. We can either have 2 answers like we've seen so far, or no answers or 1 answer. So let's check out this problem here. Here again we've got the situation where we need to isolate the absolute value. So we need to remove this 5 that's being added to the absolute value of 2x minus 3. So the way we do that is an opposite operation. So this 5 is positive, so to remove it, I'm going to take it away. And that will cancel out the 5 on the left-hand side, but what I do to one side, I must do to the other. So I take that 5 away, and what we get is a different scenario here, because we're still left with this 2x minus 3, but now we have it equal to 0. And what's curious about this is that we're supposed to figure out the 2 numbers that, well, or a number that when we put it in for x, we end up with 0, being just no spaces from 0. So what we can do, since there's no 0, positive 0, negative 0, 0 is just 0, it means nothing, we're only going to end up with one solution. We only need to find the number for x that when we multiply by 2, subtract 3, we end up with 0. So the way we'll do that is, again, we'll just set that 2x minus 3 equal to 0. And so when we go ahead and solve, we'll have to do an opposite operation again. We'll have to add 3 to all sides. And then we'll have to bring down what we've got. So we've got a 2x, and now it equals 3. And when we go ahead and divide to solve, we end up with a fraction. That's okay. Sometimes we get fractions. And we have 3 over 2. Now 2 does go into 3, so we could write it as a mixed number as well. But we're only getting one answer. So I'll just leave it in the improper fraction form, and that's okay. We can again we'll write this as 1 1/2 or 1.5. But notice that we don't have 2 solutions. And the reason we don't have 2 solutions is because the absolute value equals 0. So whenever the absolute value equals 0, we're only going to have one solution, the 3 halves. So we can even still put this in a solution set by practicing this. The solution set is just one number, and it's 3 halves. So there's a situation where we only have one answer, and it always happens when your absolute value equals 0. If your absolute value equals a positive number, you always end up with 2 solutions. Well, here's the last scenario, number 7. And this one is when we have no solutions. So let's take a look at an example. Let's say we had 2, then a minus sign, parenthesis, go with an x plus 7, and we'll say it equals 9. So again, we've got the situation where we need to clear the stuff that's being done to the absolute value. So the way we're going to do that is we're going to move this 2 to the other side. So this is a positive 2, not a negative. You always look at the sign in front of the term. And so I'm going to take away 2 from both sides. So when I do that, still left with that minus sign that's in front of the x plus 7. But this time, it now equals a positive 7. So now we still need to undo this negative sign. So the way we undo that negative sign is we divide or multiply by a negative. So if I divide by negative 1, what that does is it cancels out the negative sign on this side, leaving me just with what I want, the absolute value by itself. But what I do to one side, I must do the same to the other side. And so when I go ahead and do the work here, I have x plus 7 inside some absolute value bars, but it equals now negative 7. So let's think about this. Can we have an absolute value equaling a negative? No, because of this negative sign right here. That negative sign prohibits us from going any further. This negative sign means that we don't have any solutions. So there are no solutions. No values of x that make that true. So if we went ahead and tried to solve for it, we would have to subtract 7 from 7 and 7 from negative 7. And if we go ahead and plug those answers back in here, we would get something that doesn't make sense. It doesn't equal that number. And so whenever your absolute value, once you've isolated it, there's nothing left in front of it, equals a negative, we have no solutions. So we can write the answer a couple different ways. We can use this symbol here, which means no solution, or we can also call it an empty set. And an empty set just means there's, again, no solutions. And you can represent that answer with no numbers inside your solution set. So those are the three different types of answers. If we have a positive number that the absolute value equals, we get two answers. If it equals a 0, we have one answer. If it equals a negative, like it does here, then we end up with no answers. So those are the different scenarios that you'll end up encountering on tonight's homework, and I wish you success.